This is my Mechatronics 210 assignment. My name's Ethan Kanashak, part of Team RoboDobo, and this assignment was to develop a cosine function that takes a decimal into a 3-digit integer using the propeller microcontroller. The function coded in this assignment is the Taylor series of cosine x. Our first step is to get cosine x to have an input of x decidegrees. We do this by multiplying pi over 1800 to each variable of x in the series. We also multiply 1000 the cosine so that the output of the function is an integer with 3 significant digits. The combination of multiplying by 1000 and transforming our x input into decidegrees gives us the variables of 1000, 1523, 3866, 3926, along with their corresponding 10 to the negative power inputs. For now, we will only be using the first 3 inputs of the Taylor series. The left-hand side computes the cosine function, where our first term is only 1000, our second term 1523 with 2 decidegree inputs and divided by 10 to the negative 6. Our third term is 3866 multiplied by the power of 4 for decidegrees and multiplied by 10 to the negative 16. Our fourth term currently unavailable. To compute the cosine of the quadrant, we have the first term subtracted by the second term, then the third term is added to that sum. On the right-hand side, we ask the user to input a decidegree angle between 0 and 901. If the value is too high, then the program will ask the user input a value that is between 0 and 900. Once the value is between 0 and 900, the computer will run the function to compute cosine. Once the computer runs this function, the terminal will print the text for the cosine of the angle, and a new line will form, and the function will repeat again. This graph shows the propeller function on top of the cosine function. As you can see, the propeller integer values start to deviate from the cosine values the closer you get to 900 decidegrees. This is shown on the left-hand side of the screen, where the propeller values are inconsistent with the values gotten from the actual cosine function. In order to fix this issue, we can add a fourth term to our function on the left-hand side in order to increase the accuracy gathered by the cosine function on the propeller. We can enable this block that has values of 3926 with 6 decidegree inputs divided by 10 to the 20th. Enabling this block allows us to subtract our fourth term from our third, second, and first term computations. Turning on our propeller and compiling our code, we should be able to put in 900 decidegrees, and now we get a value of -1,